The blades of an electric fan rotate in a clockwise direction and complete 5 rotations per second. Okay, so let me write this down. 5 rotations per second, so for 1 second. Point B, so that's right here. Point B is on the tip of one of the fan blades and is located directly above the center of the fan. So while I'm reading, I'm constantly looking at the picture. So this is point B. This is at the tip of one of the fan blades, and it's located directly above the center of the fan at time equals 0. Okay, seconds. Okay, and then as indicated in the figure. Okay. Point B is 6 inches from the center of the fan. Okay, so let me draw another picture on the bottom. So we have the circle part, and then we have this base part, and then what it says was this is the center, okay, and it is the point B, so this point B is 6 inches from the center of the fan. So from here to here, that's 6 inches. And so since this is the center, this is like the radius, and so this is also 6 inches. Okay, now we continue reading. It says the center of the fan is 20 inches above the level table on which the fan sits. Okay, so this would be the table on where the fan sits. And the center, so that's right here, the center of the fan is 20 inches above a level table on which the fan sits. Okay, good. So this is 20 inches. As the fan blades rotate at a constant speed, the distance between B and the surface table periodically decreases and increases. Okay, that makes sense, right? As B is here, that's high, then it goes here, then it's low, 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 and then it goes back to high. Okay, that makes sense. The sinusoidal function H, okay, sinusoidal function H models the distance between B and the surface of the table. Okay, so B and the surface of the table in inches as a function of time t in seconds. All right, let's fix this information up a bit before we proceed, okay? So we already know from the center to the tabletop, it's 20 inches. And we know that this radius right here is 6. So to find this, we do 20 minus 6, which is 14 inches, okay? All right, so another thing that I would like to discuss is that this would be our maximum, and this here would be our midline, and then this here would be our minimum, okay? All right. And just to be clear, since from the center to the tabletop it's 20, and we have an additional 6 inch here, from all the way on top to all the way on the bottom, that would be 26 inches. Okay. All right, now let's proceed. Here it says the graph of H. Okay, so graph of H, so going back, sinusoidal function H is the distance between B and the surface of the table, okay? So the graph of H and its dashed midline for 2 full cycles is shown. 5 points, F, G, J, K, and P are labeled on the graph. No scale is indicated and no axis is present. Okay, determine possible coordinates T, which is our X, and T was in seconds. H of T was the distance between B and the surface of the table, and that was in inches, for 5 points. Okay, so let me fix this up a bit. So this was seconds, and this was feet. Okay. Now, keep in mind, when we were at its most highest point, and these are maximums, when we were at its highest point, the first time it was at its highest point, remember here it says at time t is 0 seconds. Point B is on the tip of one of the fan blades and is located directly above the center of the fan. So that means when T equals 0 seconds, it was at its highest. So in the beginning, when T equals 0, it was at its highest, the maximum, which was 26. Okay? The reason why we said 26 is that you look at this picture here. B was at its maximum, 26. Oh, I keep writing feet. Oh, no, inches. Inches is correct. So this is inches. I'm sorry. Okay, so we got 0, 26 could be a possible coordinate for F. And let's continue this idea over here. And remember, the maximum is still 26 inches. Now, what number would go in here? Now, that's a very good question. So remember, this fan goes 5 rotations per second. So I want to know how many seconds would it be for one rotation? Okay, so in order to do that, I do 1 divided by 5, and that'll be 0.2 seconds, right? Because in 1 second, I have 5 rotations. So 1 divided by 5 is 0.2 seconds per rotation. So in that case, to do 1 rotation to get back to that top, I have 0.2 seconds later. So I'll write 0.2 seconds here. Okay. Now, remember, whenever you graph a sinusoidal function, whatever we had from here to here, this part would be the half mark for the x. So I had 0 and 0.2. So, I mean, we can do this in our head, but I'm just going to show you the math. So 0 plus 0.2 divided by 2. So 0.2 divided by 2 is 0.1. I mean, we kind of can do that in our head, but just so you know how we do the future calculations for the other parts. So I'm just going to erase this. And then now, remember, this is our minimum, right, because it's at the bottom. And the minimum, if you remember, the minimum that this point can be is 14 inches. Okay, so let's put 14. Okay, so far we found the coordinates for F, J, and P. Now let's do the same idea we did between F and P. We did half, and we got this. So now we're going to do the same for G. So from 0 to 0.1, we're going to go find the half. And what we do is 0 plus 0.1 divided by 2. 0.1 divided by 2 is 0.05. And that's how we got the x coordinate for G. Now, keep in mind, this is the midline, and the midline is the center. So when we look at the midline right here, we see that it was 20 inches. So here, this is 20. Now, just like we did the half between here and here, we're going to do the same thing, the half between here and here. So I'm going to do 0.1 plus 0.2 divided by 2, which is 0.3 divided by 2, which is 0.15. So it's 0.15, and notice that the midline is still 20 inches. So we finished all the coordinates, so that part we're done. So part A is finished. And now let's look at part B. It says the function h can be written in the form h of t equals a sine b times t plus c plus d. Find the value of constants a, b, c, d, e. Okay, so we're going to have to do it over here. Let me just write that again right here. Okay, so when I look at the graph, this will probably make it easier for me to follow along. So we like to always start with the midline. So the midline is right here, 20. And so this is the midline. Okay, so let me label that. So this is the midline. And so that was 20. What else is easy to plug in? Well, we know that when time was 0 seconds, the maximum was 26. So that's the h of 0. So let's plug that in. So when I'm plugging in h of 0 or 26, and then everything else I'll plug in later. So the time here is 0. And then I'll copy down the C. Now, how do I get the A? Well, A is quite simple. A is the amplitude. So A is from how high above the midline was it, or high below the midline was it? Well, from here to here, it was 0.05 for the X, but we're not putting the X, we're focusing on the Y. So what was it between 26 and 20? It was 6. So from here to here, it was 6 up, or from here to here, it was 6 down. So I'm going to put the amplitude was 6. Then I write down sine. Now, what would be the B? So remember, anytime we're dealing with period, period is 2 pi over b. Okay? Now, what was the second per rotation? It was 0.2. So I'm going to do 2 pi over 0.2. You know what? I'm going to change this to t because I don't want to get confused. I got to put this number for b. So let's say in order to find b, we're going to do 2 pi over the time period, which was 0.2. And then when you do the math, 2 pi, and then remember 0.2 is the same thing as 2/10. And when you divide by fraction, you keep the first fraction the same and you multiply by the second reciprocal. So these cancel. And so we're left with 10 pi. So this here is 10 pi. Now, just in case, I'm just going to go back. If I were to do period from the beginning and did 2 pi over b, this would be 2 pi over 10 pi. This cancels, and notice that becomes the second per rotation. Remember, 1/5 is the same thing as 0.2. So that's how you can, reverse check. So far we found that A was 6. That was the amplitude. How high was it from the midline? 6. B, we just figured out was 10 pi. C, we figured out was, we didn't figure out yet. And then D was 20. Okay, so let's proceed. So now we're just doing algebra here. So 0 plus C, that's, okay, so that's 0 plus C, and that was C. And so we have 26 equals 6 sine 10 pi C plus 20. Then opposite of plus 20 is minus 20, so I do that on both sides. Then the opposite of multiplication is division. Divide both sides by 6, so I'm left with 1 on the left. And then we have sine of what will give me 1? Well, sine of pi over 2 will give me 1. So therefore, 10 pi c is the same thing as pi over 2. So you cancel the pi's. So we have a 1. And so 1/2 equals 10c. Divide both sides by 10, which really means multiply by 1/10. And so c is 1/20, which becomes 0.05. So therefore, c is 0.05. Okay. Now, it says, refer to the graph of h in part A. Okay, so the graph in part A, so that's up here. The t-coordinate of k is t1, and the t-coordinate of p is t2. Okay? And it says, on the interval t1 comma t2, which of the following is true about h? Okay, so here it says k and p. So let's look at k. K here, they said the t-coordinate is t1. And then the t-coordinate of p, that's this one, is t2. And so what is true? Well, it is positive. Now, how do you determine if it's positive or not? Basically, if this is the midline, anything located above the midline is positive. And as you can see, it is above the midline, so it's positive. So already we can eliminate anything with negative. And now, what else is happening? Well, it went from 0.15 to 0.2. But to be more specifically, it is increasing. Okay. Now, let's look at C Roman numeral 2. On the interval t1, t2, describe the concavity of the graph of h and determine whether the rate of change of h is increasing or decreasing. All right, so if you look back to here, this part right here that we were looking at is concave down. So it is concave down. And when it's concave down, this means that we have a rate of change that is decreasing.